Okay, looks like we're ready to roll.
That's what you think.
And we only got 12 questions.
Woohoo!
And 2 of them are, you're going to tell me what they are, the first 2.
And then I'm going to mute down. Let me get to it real quick. Those answers I know are yes and yes. I like those answers. Those answers I know.
Apparently, Brother Bennett had office hours today and recorded it, and he discusses the difference between central limit theorem and the law of large numbers.
Good. I'm going to have to go back and watch it.
But
Yeah, me too.
that would help. I kind of have an idea, but then I kind of second guess myself.
Yeah.
Yeah, it's really hard to differentiate between the 2 of them.
Well, Molly agrees with you.
Well, I watched the video, and the video confused me even further. So it's like, hey, state of confusion, party of 1, here we come.
Okay, who wants to be the reader today of the questions?
You going to read, John?
Yeah, I'll read.
All right.
Guys, as long as you guys have answers or can explain, okay? When you are taking a sample size of n equals 5, what is the shape of the distribution of the means histogram when the parent population is right skewed?
I can't remember.
I think when the number is that small, it would be right skewed.
I think so too.
To go above 30, right?
Yeah.
30 or above. Or it could come to get probably to approximately 0 or normal.
Okay.
So this one, I don't know if it quite would get all the way back to normal, but it should be pretty close.
So it would be skewed right or normal?
3 would be right, and I think 4 would be normal because of the
size is.
Yeah, the size of the sample.
Yeah, it's a bigger sample size. Okay. Number 5, here we go again. When you are taking a sample size of n equals 5, what is the shape of the distribution of the means histogram when the parent population is normally distributed?
Normal if it's already distributed, normally distributed.
Yeah. Well, we're going to have it normal when it's 100 and normal when it's 5?
If it's
normally distributed.
Yeah, even though it is only 5, it's already normally distributed.
Okay.
Well, the other one was right skewed.
Oh, it was right skewed. I misread it because, yeah. And then number 6 is probably going to be normally distributed. Normal too.
Yeah, it should be.
Yeah.
Because it's already normal.
Yeah. Okay, number 7. When would the distribution of means be normally distributed? Choose all correct responses. I say A and B.
Data are drawn from populations. It should be A. We already answered that one.
Yep.
I just got a phone call with 10 zeros. It's kind of interesting.
Oh, those are, I've gotten those before. Those are not. Those are usually Verizon Wireless wondering where something is.
Yeah. So it should be A and B should be.
That's what I'm thinking.
Okay. Data are drawn from a population. It wouldn't be C because it would still be right skewed on a small.
It could be D though, because we said it was D in question. We said it was normal, yeah, in question 4.
Yeah, I think D would be right as well.
So A, B, and D?
C's out for sure.
Oh, yeah. Which of the following gives the best explanation of the central limit theorem? Oh.
Well, it's not the second one.
Not B.
If the sample size is large, the shape of the distribution of the sample means will approximately be normal.
I was thinking it'd let us pick more than one, but it won't. It's got to be one of the
Yep.
four.
Okay, let's see. What is the central limit in study of DDE levels? South African woman.
There's a summary at the bottom, John. It says the distribution of sample means is normal when X bar is normally distributed or when, thanks to the central limit theorem, our sample size is large.
Right.
So I would say D.
D works for me.
I'm pretty sure it's not C. I know it's not B.
And A would be correct, but it doesn't have anything to do with the size of the sample. It's just the normal distribution. And so I'm thinking be D.
Me too.
Which one for 8?
D is in David.
D is in David. Okay.
Yep.
Okay.
Let's see.
Okay. C was large. We can be assured that sample mean going from more.
Sample distribution is possible means for us.
We observe simulations. If sample size is large, random variable will be approximately normally distributed. In other words, the sampling distribution of the sample mean, good heavens, all this foreign language crap, will be approximately normal at the same samples. Oh my gosh. There, that's my answer to it all. I'll fall on the wrath if you want me to and see what we get on this.
On number, whatever that is. Whatever.
8.
Actual limb.
If you go into it, yeah, I read it and it's.
Sample mean X even though, oh, I don't know. It's a good question. About it.
I don't know.
So, 9.
What is the mean of the distribution of sample means? If you have X be the random variable with population mean of 10 and the population standard deviation of 6. Suppose you have a sample size of 36. How do you figure this? I've seen this formula before, but how do you figure it? What's the formula?
I think it's just I think it's just the means. But
I
yes, I
think
that's the way it was in the homework.
well, I
Here,
read
you'll find
part
my
of it
homework.
and I thought that was that. The standard deviation is 6. That would answer 10.
Yeah, the deviation is 6. But now, so there's the first one's not a calculation, but the second one is.
How's the second one a calculation when it lists that the standard deviation is 6? Are we not just taking the information it's giving us, or we have
I think
to do lovely math? Ugh.
I think this is the one where we do 6 divided by the square root of 36.
Sorry, Kevin.
Hi, Kirk. How you doing?
So I think that's 1.
Number 10.
Yeah, because distribution of the sample means we take it, the standard deviation divided by the square root of the sample.
Okay, 6.
The
Divi-
square root of 36
Oh my gosh.
as well.
I think you're right. Yeah, because square root of 36 is 6. 6 divided by 6 is 1.
Calculator, you got it.
Sorry, I had a little conversation with my kid there. So what did we decide for 9? Is the 9?
It states the sample means is whatever the means is. It's the sample means.
Okay, so 10 then.
Yeah,
Yeah.
Okay.
And then 10, we got 1.
10
is
we
1.
figure is 1 because square root of 36 is 6. Divided by 6 is 1.
Okay.
I think Molly's right on this. I hope. I know I'm not.
The distribution of the population if
Yep.
sample. What should the shape? So is
Have the one credit card offer.
I think it'd be normal, wouldn't it?
Yeah.
up here? Doesn't tell us.
Okay, but I'll do it through my own bank.
It's got to be a.
Okay, it's
Great.
less than.
30. Oh, it's greater than 30, so it should be okay. So you should be right on normal.
Should be normal. Okay.
The sample's going to be greater than 30.
What theorem would justify the last response? Would be the large theorem of large law of large numbers.
Mm,
Actually, I'm going to go with central limit theorem.
Good for you.
Because the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean. So it just means everything's kind of coming together the more numbers you have.
Okay.
But with the central limit theorem, if your sample is large,
yeah,
then you get a sample, a distribution of sample means is normal. It's normally distributed. So I think it's the central limit theorem.
Okay. Going with it. Let's see what we got.
Okay.
One and two are correct.
Yay!
3, 4, 5 correct. 6 correct. 7 correct. 8 correct. 9 correct. Yay. 10 correct.
we
Good
leave-
job, Molly. 11's correct and 12 is correct. We got 100.
so we left it as a central theorem.
Central limit theorem, yes.
Okay, and then on, just want to make sure for Molly, on number 8, we did number D or C? Number D?
We did D as in dog.
Okay. Because the way you read it, you could almost take it the way that she was going with it, where I almost would second guess myself and think it possibly could be C too. But
Yep.
I second guess. Yeah, I second guess myself in this class all the time. That's half the problem.
Now we're talking about question 8.
Yep.
Okay, so that's the
Yeah.
one where the law of large numbers would come in.
Okay. But then why is it saying, so you're saying which one would be the law, the
C.
C would be the law of large number. Okay.
Yes.
Okay.
And that's why D is the other one.
Okay.
okay, well, outstanding job.
All right.
Way to go, guys. I was going to tell you, John, I finally got 100 on a homework quiz over the weekend.
I don't
First
want
time ever.
I don't want to talk to you anymore because mine are bombing. Mine are just collapsing. It's like, oh.
It took me, I had to work through each and every one of them, but I told myself, especially, I didn't get 100 on the first shot. But again, I knew kind of which ones I'd screwed up on, and I did it and got 100. So pretty darn proud of myself.
Good for you.
Yeah, finally.
You're ahead of me because I'm not getting them. Ugh. All
Good
right.
job, guys.
Have a good
Run
night,
off to the-
everybody.
Yep.
Have a good night.
You
Thanks,
too. We'll
all.
see
They
you
do seem
Wednesday.
harder, Molly. You have a good one.
Brett, let me know on the homework. Oh, he already left. Okay. Good night, guys.